We are delighted to have been awarded and been part of the Department for Transport Clean Maritime Demonstrator Competition. The award is part of the UK Government's Net Zero and Maritime Decarbonisation strategy to promote innovation in the space and to support research and development for the reduction of greenhouse gas emissions by the UK's maritime sector as set out in the Clean Maritime Plan and support the transition to net zero by 2050. In our application, we set out to achieve 4 key items: to develop a marine solid oxide fuel cell battery hybrid power system, which is an alternative to a diesel generator to produce electricity capable of providing the base power hotel load for our large cruise ships, both when they are at sea and, more importantly, when they are in port. We want to operate these systems with either liquefied natural gas or eventually hydrogen, and also make the best use of waste heat to make the whole system as energy efficient as possible. To develop a roadmap for the technical and economic viability of multi-megawatt power SFOC power systems. To provide the design case for fuel cell powered vessels without the need for internal combustion to further improve efficiency. And finally, develop a plan for a small-scale trial on board a vessel to understand the technical and operational requirements. To achieve this, we partnered with the University of Southampton, Ceres Power, Shell and Lloyds Register. The award will enable vital and extensive research into the feasibility of using SFOC technology to replace the use of diesel generators for the provision of cruise ship, hotel and port load. It will demonstrate the potential reduction in greenhouse gas emissions as well as improving the energy efficiency for existing ships. We will do this by building, together with the university, a cruise ship energy model using data from the LNG-powered P&O Cruises Iona, and then Ceres will model the fuel cell systems, including heat recovery, through the full range of in-port and at-sea operations to establish both energy demand and emissions profiles. We then determine what the impact on the vessel design would be with Lloyds and implications from switching from LNG to hydrogen with Shell. Carry out a design screening and safety assessment against the rules and examine the safety implications. And finally, complete a techno-economic analysis of the proposed design outcomes. Carrying out research and development into alternative fuels and technology is essential for us to be able to meet both our own and society's goals to reduce air emissions and our decarbonisation targets. We all aspire to net carbon neutral operations by 2050, and without partnerships like this, we will not be able to achieve our shared goals. We've invested significantly on new ships and new technology, as have our partners in this project. The cruise sector is the most visible shipping sector, and we are committed to constant innovation. The use of technology is critical and has allowed us to be the industry leaders in the application of LNG in cruise ships, advanced air quality systems, shore power, and other energy-saving devices like air lubrication. All of these have allowed us to meet and exceed our energy-saving targets and help us towards a net zero future. I'm extremely proud that Lloyds and the University of Southampton are together with us in the project. Southampton is our home port, and leading the way in reducing shipping emissions here in the UK by installing shore power and already having LNG supply in place with the help of Shell. It is also fantastic to have a UK-based fuel cell specialist, Ceres Power, together with us on our journey. The project will provide insight for the future and for the next generation of ships and help us get our first net zero ships on the water in the next decade. Protecting the environment in which we sail and that of the communities which we visit is a vital priority for us, and reducing our emissions to near zero when we are in port is fully aligned with our sustainability goals.